Now let's go for 5.5, question number 5.5, and question number 5.5. Let's read that. A bar magnet of a magnetic moment of 1.5 joule per Tesla lies aligned with the direction of the uniform magnetic field of 0.22 Tesla. What is the amount of work done required by a external torque to turn the magnet so as to align it with the magnetic moment? Align its magnetic moment normal to the field of direction and also opposite to the direction of the opposite to the direction opposite to the direction. Now let's understand the question what they are asking you. There is a bar magnet, right? So let us suppose there is a bar magnet, right? There is a bar magnet like this. There is a bar magnet and there is a magnetic field. This is the magnetic field, right? Now what they are asking, this bar magnet has a magnetic moment of 1.15 and its external magnetic field has a magnetic strength of 0.22 Tesla, right? What is the amount of work required by an external torque to turn the magnet so as to align its magnetic moment normal to the field direction? So if you put this magnet itself like this, so it means you need to do a work from this position to this position, right? So this position to this position. So let us suppose this is north and south. So this position to this position you have to do a work, and at the same time it also in this question they are also asking you have to make opposite to the full direction. So if you put here opposite to the field direction, so our magnet's direction will like this. So the angle now turned is 180-degree, right? So we will discuss each and every case one by one, right? First of all, what they have provided, you put that magnetic moment is equal to 1.5 joule per Tesla, right? And the magnetic field, strength of the magnetic field, they have provided you 0.22 Tesla, right? What is the amount of work done required by an external torque? So definitely when you try to move or rotate, so what will happen? You have to do a work. So rotational work done by this rotation will be how much? So we have to find out the work. Now let us suppose theta 1, that is initially it was 0 degree because it is along the magnetic field. Magnet is along the magnetic field, and in this case, this is a case A, right? Okay, case, not a case A, it is a section 1 or a, see, this is question in 5.5 A, and in 5.5 A we have to solve for a part 1, that is normal to the field direction. So when it is normal to the field direction, so what will be the theta 2? Theta 2 is equal to 90-degree. So what is the formula for the work done? So work done will be, use this formula, work done is equal to minus mb cos theta 2 minus cos theta 1. Now it's how much? So put the value so that you can get the result. So this is minus m means 1.5, b means 0.22 into cos theta 2. Cos theta 2 means final theta 2 is cos 90 minus cos 0. So the amount of work done will be approximately or 0.33 joule, right? So this is the work done in case 1. Now case 2, when you observe case 2, so theta 1 is initially 0 degree only, but theta 2 becomes 180-degree, right? So what will be the work done? So work done is equal to again minus mb cos theta. So minus mb means minus 1.5 into b is 0.22 into cos 180-degree minus cos 0 degree, right? So this is approximately minus 1.5 into 0. So one thing I think 0.22 into cos 180 minus 1 into minus 1. So this will be approximately double. So this will become 0.66 joule. So I hope you have understood this one. So you have got this work done. So work done in case 2, right? Work done in case 2, right? So I hope you have understood this one. Now the part B of this question. What is the torque on the magnet in the case 1 as well as 2? So whenever you will try to rotate, so what will happen? Torque will be there. So change in each case. In first case, change in angle is how much? 90 degree. In second case, change in an angle is how much? 180 degree. So we need to find a torque. So what is the formula for the torque? Torque is equal to, just recall your formula. Here angle of rotation, that is theta, they have provided you 90 degree for the case 1. B case 1, theta is equal to 90 degree. So torque is equal to mb sine 90 degree, right? So just put the value. So this will be 1.5 into 0.22 into 1. So this will be 0.33 joule. Now case 2 where theta, change in theta, that is theta 2 minus theta 1, that is equal to 180 degree, right? So can you find a torque? So torque is equal to mb sine 180 degree. So sine 180 degree is itself is equal to 0. So case 2 torque will become 0 degree. So I hope you have understood this question very well. So let's go for next question. A closely wound solenoid of 2000 turns and the area of cross section is this one, 0. This one, carrying a current of 4 ampere, suspended through its center and allowing it to turn in a horizontal plane. So let us suppose draw it, right? So there is a solenoid like this. There is a solenoid like this, and it has been suspended with any string. Let us suppose it has been suspended like this, and this has been placed in the suspended through its central. So what is the magnetic moment associated with this one? So first of all, what they have given you, they have given you number of turns, that is n is equal to 2000, right? And area of cross section is how much? 1.6 into 10 to the power minus 4 meter square. And the carrying current is how much? I is equal to 4 ampere, right? Got it? So what is the magnetic moment? So A part, magnetic moment associated with this one is equal to NIA. So N is equal to 2000, I is 4 ampere into area is how much? 1.6 into 10 to the power minus 4 meter square. So when you do this calculation, so this will be how much? Let's do the calculation, right? This will be approximately 1.28, right? It will be, magnetic moment will be 1.28 joule per Tesla, right? So this is the part A. Part A. Now part B, what they are telling. What is the force and the torque on the solenoid if a uniform horizontal magnetic field, let us suppose there is a uniform horizontal magnetic field is there, and it has a magnetic field has a strength of this Tesla, set up an angle of 30 degree with the axis of the solenoid. So this is the axis of the solenoid and this is making an angle of 30 degree. So how to do this one? So what they have provided you, strength, that is equal to 7.5 into 10 to the power minus 2 Tesla, right? And we have already got the magnetic moment of this solenoid is 1.28, right? 1.28. Now the angle making by this solenoid or central axis of the solenoid is equal to 30 degree. Okay, so to torque, how you will find torque? Torque will be equal to mb. Just now we have done this for this question, that is equal to mb sin theta. So this is equal to 1.28, so joule per Tesla. So this will be 1.28 into b is equal to 7.5 into 10 to the power minus 2 into sin 30 degree. So this amount of joule will be there. So answer will be how much? So just pause the video and calculate its torque. So I hope it will be approximately 4.8 into 10 to the power minus 2 Newton meter or joule, whatever you can write, or joule, right? So I hope you have understood this one. So always either joule, unit will be either joule or Newton meter. I hope you have understood this one. Got it? Now let's go for next question, that is equal to 5.7. There is a short bar. There is a short bar magnet has a magnetic moment of 0.48 Tesla. Give the direction and magnitude of the magnetic field produced by the magnet at a distance of 10 centimeter from the center of the magnet. First case, the axis and the equatorial lines, normal bisector. So see, there is a short magnet. Let us suppose there is a north and south, right? And magnetic moment for this short magnet, that is m, they have provided you 0.48 joule per Tesla. Given the direction of magnitude, give the direction. See, they are asking that let us suppose this is a center. So from center, either at this point, that is A, or at this point, that is A. Both are at 10 centimeter. 10 centimeter. Both points are at a 10 centimeter distance, right? 10 centimeter distance, right? We need to find the. See what they are asking. Give the direction and magnitude of the magnetic field. Magnitude of the magnetic field, right? So just to go through it and again try to understand this. So first case, we will handle first case, right? It's m is equal to 0.48 and the distance they have given you 10 centimeter, that is equal to 0.1 meter, which will be more suitable. Magnetic field at a distance from center of the magnetic field is given by the relation at a distance d from center of magnet magnet in axial line. Axial line means we are considering this point, right? So this is the case 1. So we are discussing case 1. So axial line. So what will be the formula for the axial line? B is equal to mu naught by 4 pi into 2m magnetic moment divided by dq. So put the value mu naught by 4 pi, that is equal to 10 to the power 7, because we have a formula, we know that mu naught by 4 pi is equal to 10 to the power 7. This you can use into 2 into m is how much? Magnetic moment is 0.48 divided by dq means 0.1 whole cube, right? So it's a 10 to the power minus 7. Again, I'm forgetting this one, so just calculate it. So this will be approximately equal to 0.96 into 10 to the power minus 4 Tesla. So this is the case of B. Now we will discuss about this case, that is A. So if you want to find a magnetic field at an equatorial point, magnetic field at an equatorial point will be how much? So the formula which we will use is equal to mu naught by 4 pi into m by d cube. So it is just a half. So this will be how much? 4 pi into 10 to the power, sorry, not 4 pi. So again we have to use 10 to the power minus 7. 10 to the power minus 7, just put it. It's equal to 10 to the power minus 7 into magnetic moment is 0.48 divided by d cube, that is equal to 0.1 whole cube. Now while solving it, so you will get 0.48 into 10 to the power minus 4 Tesla. So this is the strength of the magnetic field, right? Now the thing is, what is the direction in this case? So the direction of the magnetic field will be always in the north to south direction. Direction is from north to south direction, north to south. So if you want to know more details about the direction, so you can visit to our channel. You can go through the theoretical section so that you can understood, right? So I hope you have understood this question in a proper way. So if you have any doubt, you can ask or a comment so that I can communicate it with you. Okay, I hope you have understood this one. Thank you for watching this video.